Okay, so let's start off by talking about plane reflection. So this means it's going to be reflection off of a flat surface. So the general definition of reflection is it's going to be the bending of a wave when it bounces off of something. So in this picture here, we have a mirror, and so it could be a mirror made of metal. It could be water that is acting as a mirror. And so light is going to come in, it's going to be reflected off of the mirror, and then it's going to go into your eye. So this is going to be the universal symbol for an eye. So that light's going to come in, bounce off the surface, go into your eye. So the law of reflection is going to be that if we make a line that is perpendicular to the mirror, that's going to be called the normal. We could measure this angle here, and we could measure this angle over here, and they would be the same. We could also measure this angle, and we could measure this angle over here, and they also would be the same. So that's the law of reflection. So we can use this to show some properties of reflection. So the first property that I want you to notice is that the image in a mirror is the same distance behind the mirror as the object is in front. And so here we've got a mirror like this, okay, then this is the ground down here, and now we need to have an object. So I like to use a candle. So this is my representation of a candle, and I'm going to label this as being O for the object. And what we want to do is to try to figure out where is the image of this object going to be located at. And so again, up here is going to be your eye, so that light from the candle is going to go in all different directions. So some of the light goes this way, some of the light goes this way, some of the light goes this way. So light from the candle goes in all directions. But the light that you're going to see is the light that's going to bounce off the mirror and then go into your eye. So for example, you're not going to see this light wave right here, but you might see a light wave that goes in this direction, hits the mirror, and then bounces into your eye. So that if we were to make a perpendicular and then measure this angle and measure that angle, they would be the same. Now, what's interesting is, let's take this line here and continue it on the other side of the mirror. So we're going to take this one and keep going in the same direction on this side, and what we would find is when we reach this height over here, that's where the candle flame would be located at. And then we can do the same thing for the bottom part. And so now it's going to come in, it's going to bounce off the mirror, and then it's going to go into your eye. And again, we could measure, if we wanted to, we could put a line right here, and we could measure that, and we could measure that, and those two angles would be the same. So if we continue this one back behind the mirror, we find that it goes down to here. And so now that's the bottom of the candle, so that we can make an image of the candle. So this is going to be I for image, and then this is O for the original object. And by using the law of reflection, we have shown that an image is the same distance behind a mirror as the object is in front of the mirror. So I encourage you to try this when you get home and you're looking into your mirror in your bedroom or in your bathroom. Look at where your face looks like it is and compare that to how far your face is from that mirror, and you'll notice it is the same. So what would be a practical application of this? Miniature golf. So in miniature golf, okay, so let me draw here. So here is the the hole or the that you're playing. Here is the ball. You're trying to get it to go into a hole. What could be simpler than that? Just hit it to the ball, hit it to the hole. Well, the problem though is that there's a barrier right here. So you can't hit it directly into the hole. You're going to have to reflect it into the hole. Okay, now how can we use this idea down here that a image is the same distance behind a mirror as the object is in front of it? Well, we're going to pretend that this thing right here is a mirror. And we're going to look at where would the image, if this was the object, where would the image be? So the image would be over here, and it would be the same distance from here to here as it is from here to here. Now, that's not a very good picture, but you get the idea. So all you've got to do is aim for the image. So you're going to take your putter, aim for the image over here, and then when the ball gets to this rail, it will be reflected and it will go right into the hole, more or less. So you also have to take into account that the ball is spinning. There might be debris on the green right here that might get in the way. So this is, it gives you an idea for where to hit the ball if you want to reflect it and make it go into the hole. Now, let's say that you're fancy and what you want to do is do a double reflection into the hole. So we're going to make it bounce off the rail 2 times and then go into the hole. Where should I hit the ball? So we're going to reflect it twice, so that means we need to have 2 mirrors. So let's pretend that this one up here, this barrier, is also a mirror. So what I'm going to do is I'm going to extend this one over to here, pretending it's a mirror. And so where would the reflection of the image be? See, this is the image of the object. So we need the image of the object. So if this was a mirror, then that means that the image of the image is going to be up here. So we're going to reflect it off of this. So what does that mean? Okay, now you get out your ruler. So remember, when you go to play miniature golf, bring a mirror with you and also a tape measure and your calculator and a piece of paper. Well, yeah. All right, so here, if I draw a line from there to there, then what's going to happen is that when it gets to here, it's going to be reflected. But then when the ball gets up to here, it's going to be reflected and it's going to go into the hole, theoretically. So it gets much more problematic. That it's going to go into the hole when you do this, but try it. So remember, the next time that you go and you play miniature golf, bring your calculator, bring a mirror, bring a tape measure, bring a ruler. Wait until there's a whole bunch of people that are behind you waiting to, play the hole, and then turn to them and say, it's for science, okay? They'll really appreciate it when you do that. All right, let's take a break. When we come back, we're going to take our flat mirror and curve it.